All right, one last video talking about multi-step equations. I also wanted to cover a couple of special cases that you may come across at some point. And those special cases involve, we could have different types of solutions here, okay? So in all the previous videos and all the previous notes and lessons we've looked at, whenever we were solving an equation, we had one solution, right? X is equal to 5, x is equal to 4, x is equal to -2. We had one solution, right? Well, there are two other possibilities we can come across, and that is x is equal to all real numbers, okay, or x is equal to no solution. Okay, and what I mean by that is if x is equal to all real numbers, then we're saying, remember, all real numbers means any number that can be put on a number line. We're saying we could pick any number on a number line. It doesn't matter what it is. It could be a fraction, it could be a decimal value. We can pick any number and it would make the statement true, okay? So we could plug in any number for x and it would solve our equation. It would be the correct answer, okay? The other possibility is, what if x, there is no value for x that makes the statement true? There is no number that we can plug in into the equation and get the same answer on both sides, okay? That would be no solution. In other words, there is no solution for x, okay? So I want to look at these two examples here on question number 2 and 3. And let's solve this using the same steps that we looked at before, okay? First of all, step number 1, use the distributive property if we can here. So 3 times x is 3x. 3 times 1 is 3 is equal to 3x plus 3. Well, wow, check that out. We have 3x plus 3 equals 3x plus 3. Well, what does that mean, Mr. Pinksterhouse? Well, notice we have the exact same thing on both sides, okay? So is it going to matter whatever I plug in? Am I still going to be able to get the same answer on both sides? Well, let's check. If I plug in a 1 for x, let's say I think x is 1. If I plug in a 1 for x to both sides here, is it still going to be the same thing? Well, yeah. Let's check this out. 3 times 1 is 3 plus 3. Same thing on this other side. 3 times 1 is 3 plus 3. What's 3 plus 3? 6. So do we get the same thing on both sides? Yeah, 6 equals 6. Well, what if I tried, I don't know, let's say 2. What if I plugged in 2 for x? Okay, if I plugged in 2 for x, is it still going to be the same thing on both sides? Okay, well, yeah. 3 times 2 is 6 plus 3. And again, 3 times 2 is 6 plus 3. Well, what's 6 plus 3? 9. So do I get 9 equals 9? Well, yeah. Okay, so anytime we run into this situation here, into this situation where both sides are exactly the same, okay, we have 3x plus 3 equals 3x plus 3. It doesn't matter if it's something like that. It doesn't matter if we end up with 5 equals 5. As long as both sides are exactly the same, then it doesn't matter what x is. X could be any real number, okay? We can plug in any number for x, and we will always get both sides to match, okay? So we plugged in 1 and we plugged in 2, and we got 6 equals 6 and 9 equals 9. Those are true statements, okay? 6 does equal 6, 9 does equal 9. And 3x plus 3 does equal 3x plus 3. That is a true statement, okay? Both sides match. Anytime we have this situation where both sides match, the answer is x equals all real numbers, okay? In other words, x can be any number, and we will always get a true statement. 3x plus 3 equals 3x plus 3. 6 equals 6 when we plugged in a 1. And we got 9 equals 9 when we plugged in a 2. So any number we plug in, we'll get a true statement there, okay? The other special case we can run into is in this situation, okay? So let's go ahead and follow the same steps as we were before. Apply the distributive property. Now notice, even though we don't see it, there's a negative or a minus sign here in front of the parentheses. We treat that like it's a -1, and we're going to distribute that to each term, okay? So this guy stays the same. We have x plus 2 equals 2x, and then a -1 times x is what? Negative x, right? Now we could put a -1x, but we don't have to. Let's just put minus x, Okay, and then a negative 1 times a negative 3. Two negatives when we multiply make a positive, and 1 times 3 is 3. Okay, well then step number 2, combine like terms. I get x plus 2 is equal to, I can combine those guys together. What's 2x minus x? Well, 2x's minus an x leaves me with 1x, right, or just x. So those guys combine, and then I have plus 3. Well, now remember, the goal is we pick a variable side. Well, let's move all the x's to this side and all the numbers to this side. Okay? So if I'm moving all the x's to the right, that means I need to move this x over here, right? Well, it's a positive x, so how do I move it? What's the inverse operation? Minus x, right? So I'm going to subtract x from both sides. It cancels out, and I get 2 is equal to, well, what's x minus x? 0, right? Doesn't that just kind of go away? I'm left with 0 plus 3. Okay, well, that's an interesting situation. What's 0 plus 3? 3, right? Now, check out what we ended up with here, okay? I get 2 equals 3. Does that make any sense at all? No, that's not a true statement. That's a false statement. That's a false statement, okay? 2 does not equal 3, okay? So remember in the last example, we could plug in any number. We plugged in a 1. We plugged in a 2, and we ended up with a true statement. 6 equals 6, 9 equals 9, and we said we can plug in any number for x, and we will always get a true statement. Now compare that to what we just got. We got 2 equals 3. That's a false statement. So anytime the sides do not match, and we do not get the two sides to equal the same thing, we get a false statement, then x is no solution. Okay? In other words, there is no number that we can plug in into this equation to get both sides to match. It will never work. Okay? And we could even try that. We could plug in a number just to show you. If I plug in 1 for x, let's say I plug in 1 for x over here, we'd have 1 plus 2 is equal to 2 times 1 minus 1 for my x in there, and then 1 minus 3. So if I plug in 1 for all my x's here, let's just show that this doesn't work here. What's 1 plus 2? 3. And I know I'm kind of going outside of the order of operations here. I'm just kind of going left to right. 2 times 1 is 2. And then we have minus, what's 1 minus 3? Okay, that's a negative 2, right? Okay, well, going back to what we talked about before, we have minus a negative. What do you do when you minus a negative? You change it to addition, and we get 3 is equal to 4. Is that a true statement? No, that's a false statement. Okay, so notice, it doesn't matter what we're going to plug in, we're always going to get a false statement. So in other words, there is no solution. Whoops, forgot my O there. No solution for x.